Hey yeah, everybody, Joe here. Want to check out a puzzle today by Blobz. It is called Indexed YYSL. Not sure if that stands for something. Maybe, maybe not. Normal Sudoku rules are applying. That's 1 to 9 in every row, column, and 3 by 3 box. Shade cells using two colors such that each color forms an orthogonally connected region and no 2 by 2 area is a single color. Digits in cage cells indicate how many cells of the same color are seen orthogonally from that position, including itself. The other color blocks vision. Along an index line, the digit in the nth cell, starting from the diamond, indicates the position along the line where that digit appears. So if this is a well, these will be 1 to 2, basically on an index line. However many digits long the line is, that's the maximum number. As in, if this is a 1, it is indexing itself, but if it is a 5, then the 1 will be there in the 5th position. So these are all 1, 2, 3, 4, 5. And this one can only be 3, 4, 5. Like, actually, those are only 4. My bad. Forgot how to count. These are 1, 2, 3. And this one is 5. This one is 5 as well. So we almost have, what were the, I was not counting it. Oh, it is including itself. So if this is 1, this can't be 1, can it? Because all of these would be different colors. And we can't have that because then the yin yang would be trapped. So this will be a 2. And it's indexing the 1 to the 2nd position. So, and again here, and here, we can't have 1s in any of the boxes, basically. Not basically. That's just the way it is. So the 1 is going to be in this column, so it cannot be there. So the 1 on this line is going to index itself. It's going to put the 1 over here, and that's going to make this a 4. It'll make that a 3. It'll make that a 2. So the 2 and the 3 are indexing themselves. What else do we have? We have 1 down here only. And then the 1 won't be in the box, so it goes there. And then this is now a 1, so the 1 must go here. And then there. We're going to get all of the 1s, which is nice. Okay. What else cannot go in a, I guess, yeah, nines would definitely be okay for boxes, as they are counting both horizontal and vertical, so that would not be too hard. It's also counting it, the box is also counting itself. Um, okay. So along the perimeter, what am I thinking? I'm thinking whatever number this is, if it is not 8, but none of these are lined up on the perimeter, but is it possible that would just have to be 9? But then, if it was 9, then an entire, well, 9 would not work there. No high number would work here. As in, there's going to be a color change somewhere on this side. Because this would have to be 9. But if that was 9, then all of these would be the same color. And that would break the 2 and 3 box. So there's going to be a color change on this side. Where's the other one? It's here, isn't it? Oh, but it would be okay if it changes in the corner. But if these were 9, then all of these would be the same, and that would be broke. If this is 9, all of these would be the same, and that would be broke. So what am I saying? I'm saying I'm saying there's a color change up here somewhere, but it could be in the corner. There's a color change here somewhere, but it could be in the corner. There's a color change here somewhere. So are they there and there? What is the maximum they can be? If this is whatever color, and we have a color change over here, and it continues on to there or something, and then we go back to red, then we could not go back to yellow. But we know that all of these won't be red. At least down. Although this one can be quite a bit. Actually, this is gonna block vision, isn't it? Hold on a second. If this blocks vision, this could be 9. As long as that was a different color. It would not mean that all of these would be the same color. That's the same for here as well. So am I still saying that? I don't think I am. Let's just start with what we do know. Those are 6, 7, 8, 9. I don't like that. Mark. I'll put it in this box. However, if it does not reach at least one edge, say it just goes up and gets his entire 6, we're going to have yellow and yellow. And it would have to go all the way around since we've had to swap of color to color. Right? So this would be whatever like that. That would be 9. That would be 9. I guess that would be okay though. So where do we start deciphering this? This sees 3 of its own color, which is not very many. Oh, it does not see. So these two are different. Cannot see both of them, right? Or well, no. They could be the same color though. But that's not necessarily true. Because even if this was different, its vision would be blocked. That could still be red. It could be seeing that one, and that one could be red, and then the rest could be yellow, whatever. But, or that one could be red instead. And then those would be yellow like that. And it would still allow the perimeter to carry on however far it wanted to go. So I can't use that one, I don't think. Are some of these 9 though? I mean, I think all of these are able to be 9, as there are no second box along the wall to give me a definite yes. So, although there is a 2, let's keep going on Sudoku for now. Keep getting sidetracked. There is a 2 up here. Why not get some numbers first before I have to think? 2, 3, 4, 5. I have all the ones. Is that all I can do at the moment? Oh, I've indexed some things. So I've indexed the 1 here to the 4th position. So this is a 4. I forgot the mechanic. This is a 2. The 2 is on the top. 2 will be down here. What other one? If this is 3, that is 2, 2, 2. Four is going in one of these. I guess the 4 could still go there. If that was a 4, that would be a 5. That would be a 3 indexing itself. That would be 5. That would be a 2, 3. That would be okay. Um, 4 is in one of these boxes. It doesn't seem too wild at the moment. The 2 is here. That is. If a 2 is here, then we are definitely having a swap color. We go there, there, there. But unless this is 9. Yeah, but that's what's weird. In every one of the outside boxes, it can be 9. So I don't know where my swap of color is happening at the moment. I don't know which edge I need to reach, I guess is what I'm saying. So, 1, 2, 3, 4. This, for what it's worth, cannot be 1 through 4. I guess that's not worth much at the moment. So, have I done all the indexing I can right now, I think. Right? Do I need to look at a box with a 2 in it? A box with a 2 in it. It's only seeing one color that is right next to it. So, oh, this one is only seeing one color that is right next to it. And basically, if these two are red, then that one, that one, that one, and that one are all yellow. Unless I use a different color. It would also make that yellow. It would make that yellow. That would be at least 4. That would be okay though. If these two are red, that one, that one, and that one, and that one, and that one are all yellow, That would still be at least 4. Am I getting the 3 out of here? If these two are red... No, I guess not. Because now it goes this way. And there. Yeah, maybe not. Okay. So, 4, 5, 6, 7, 8, 9. Is it anything to do... Where am I finding my perimeter? Do I think on this 3? But even if this is red, if that is yellow, then the red can be wherever over here. Wherever it gets blocked, then it doesn't matter afterward. So I don't think I can judge anything by that. Can I force a couple of the same color? As in, I think no matter which way this goes, then these two have to be the same. I mean, they could, no, they could be different. That's not true at all, yeah. If it doesn't go right there, then they are different. These two could be the same. So, which way does this see? Oh, no. If that sees like that, then all of those are opposite, and those would be 2. But that is fine. But there would be a color swap, at least there. Is this 2 going to force a color swap then? Okay, that's if it goes to the left. If it goes to the left, there will be color swap. If it is there, then these are all the same color. That would be there, that would be there. This could go up. That would not create a color swap. So if it goes this way, then those are all the same. That, but then this color could come up around. That would not force a color swap. Actually, was I even right about this one? Those would be the same color. And yeah, it would. So that's the only way that that would force a color swap, which I assume will be the same for down here. Those would all be the same, and then there would have to be a color swap. So, but if it sees those 2, then it was like that, and they could just loop around. And then that could still be 9. Um, so how do I take that further? Finding out what this is? I don't think that helps me though, because it can go all the way up to 9. And it can be this entire edge. These don't have to be the same. But they could be. Not if it's 9 though. Or well, not if this whole side is the same color. But I don't know if that whole side is the same color yet. What do I know? Can't even tell if those would be the same. If it goes that way, then they're not. But if it goes this way, they could be. If that is 2, if it looked down, there would be a color swap. If it looked up, there would be a color swap. If it looked over, there would be a color swap. If that is 2, there's color swaps here. If it's 2 and it looks that, well, I don't know if it's 2 though. I mean, that's kind of a pretty big what if. If it's 2 and it looks to the left, then the entire outside is the same color. And the 3 outside boxes are all 9. I don't think that necessarily breaks anything even. So, I can't get anything else out of the indexing, can I? What if this is 4? this is 4, that is 3. That would be 3. That would be 5. That would be 2. That would be 3. This is 5. Let's say that is 5. That is 3. That would be 3. That would be 2. That would be 2. That would be 2. So that would be 3. That would be 2, I said. That would be 2. 3 would be in one of those. Then in any corner. I guess that would be okay. I'm not making combos anywhere. Other than where it's obvious. Not in the rows that I see or columns. Um, if that is 4, that is 3. Oh, if this is 3, oh yeah, that would be 5, that would be 2. And wait a minute. If this is 3, then these are 2, 5. Right, that would be 5, that would be 2, that would be 3. I said that wrong. Okay. What in the world? What are we doing here? Is that 4? No idea. Can 2, 3 both be that would be 2, that would be 3. That would be 5. That would be okay. It would seem. Can I get 3 out of here? If 3 goes here, it goes there. Because that would be 5. And that would have to be 3. Or, I mean... Oh, wait a minute. If 3 goes here, it puts the 5 there, and puts 3 there. Putting 3 here would put 2 there. So it would put 3 there. I think I tried this earlier. Yeah, I did. If this is 4, it puts the 3 there. If this is 5, puts the 3 there. But it can index itself. I think I am supposed to be finding the yin yang. Am I forgetting something? All self-indexing. Oh my gosh. Man. All self-indexing cells are one color. All non-self-indexing cells are the other color. Did I read that? These are both the same color. Okay, but this will get me started. Okay, all self-indexing cells are a color. Neither one of these are self-indexing. That is not either. That is not either. That is not either. That is not. I had a couple in here that were. Um, okay. Does that look good? Self-indexing, self-indexing, self, not, Alright, I suppose so. Any of those could still index themselves. Actually, this one does not. The two will not. Is there a point to that one? Okay, so if that is red, then these are yellow, and that will break it. You can't have a checkerboard in a yin yang, because by the time this yellow, no matter which route it took, when it got around to that yellow, red would be trapped in some fashion. So red does not go here. So that is yellow. For the same reason, red does not go here, because both those would be yellow. So red is either here or here, but I have to avoid it. A checkerboard again, so that is yellow. So that means this is non, or no, yellow is self-indexing, so that is 5. And now this is self-indexing, or no, it's not. I put the wrong color in there. Hold on. What did I color that yellow for? A moment of stupidity, perhaps. Self-indexing cells are yellow. This is a non-self-indexing cell. Okay. Now, start again. Same thing. If that is red, we checkerboard. So it is yellow. If that is red, we checkerboard. So it is yellow. If that is red, we checkerboard. So it is yellow. Yellow is self-indexing. 5. 3 is not now. So it is red. That is correct. 2 will be red. So that is correct. That will need to be yellow to avoid a 2x2. This is 2, that is 3. 2, 3 is going to end up like that. 2 is no longer in there. There was more lines here. That is non-self-indexing. This sees 2. It is in a square. Actually, and the 3 as well. The 3 seeing 3 red here makes that yellow. The 2 seeing 2 red make those yellow. We have to avoid a checkerboard in both those spots. We're avoiding a 2x2 here. Boxes, boxes. This is seeing, we're avoiding a 2x2. This is seeing 2 at the moment. So one of those will be red. Not sure which one yet. This has to see at least one more. If that is red, that would be 4, because that would be done. Oh no, it could see somewhere this way. Never mind. We're avoiding a checkerboard here, avoiding a 2x2. This one cannot be self-indexing. So that has to be red. That will now be avoiding 2x2s. Now this one is self-indexing, so it will be a 4. That will make this a 5 and that a 3, which are both not self-indexing. That finished this 2. That way, this could still be red. Well, I guess technically it could be yellow. However, if red wraps all the way around, and only if red wraps all the way around. But, that being said, this 4 is seeing 4 already. We're avoiding a checkerboard. Now 3. Okay, now we have our first. No, not necessarily. That is yellow. It does not stop red over here. That is not visible to 3. This one is seeing 5 though. So those are red. Avoiding a checkerboard. Red here, or yellow here, is going to have to get out to its buddies. So it will go in that path. These can still be red though. This spot, this is done. That is 5. This is done. That is 4. At the moment, this is seeing 5. It has to see another. So it has to be 6. This has to be red. And that will finish the 3. So those become yellow. So box, box, box. This one is 3 because it sees those. Now 3 is up here. 3 is here and here. Okay, we have a lot of 1s now. We have a lot of 2s. 3s we have all of now, I think. All of a sudden. It's amazing if you read the rules and then remember them, how much of a difference that can make. Remembering is always a difficult trick. For me, it seems. If this gets no more red, then it would have to be 3. So one of these at least will be red. That was compelling, wasn't it? 4. Okay, that one is yellow. This one, 1, 2, 3, 4, 5, 6. It has to get one more at least to be 7, and it can only get one more after that. So 7 if it stays there. It is 8 if that is yellow. We still haven't had a color swap on the perimeter, which is actually what I was looking for the break-in. But we see how that went. This one, 1, 2, 3, 4, 5, or 6. So it has to be 5. And that is now red. And that is now 7. This will be an 8, 9. This is becoming quite large. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is actually done. That reds that and that. That is now 8. That is now 9. But there's probably, yeah, we're avoiding a 2 by 2, or we're avoiding a checkerboard there. We are avoiding a checkerboard here. We are avoiding a 2 by 2. We're avoiding a checkerboard. Avoiding a 2 by 2. Avoiding a checkerboard. That one is seeing 5 at the moment. It must see that. That's going to take away 6 because it sees 7. And it has to see at least 8. So it has to get at least that one. It could get that one as well. Are we going to just circle the entire perimeter with red? This is 4 at the moment, but could be more. This yellow will eventually need to get up to that yellow. So what is the maximum this can be? It's 4 at the moment, 5, 6. It can't be 7 because this would be trapped. It can't be 5. It can't be 6. So it is 4 and it stops right there. So that is yellow. Avoiding avoiding checkerboard. At the moment this is 4. What is this one? 3, 6. Could get bigger. This one is 6. Maximum of 8 if those are yellow. That would maybe be okay. The index lines, actually those are all done. That is good. I don't even think I realized those were done. 2, 3, 4. That is seeing 4 at the moment. 6 is its maximum. This one, it cannot be yellow, can it? because it would only be a maximum of 3. Okay, so regardless, it has to get that one. Um, so even if this was red, this would have to be red as well. At the moment, it's seeing 6, so 5 comes out. But it could definitely still go up all the way to 9. 3, 4, 5, 6. This is just 5 or higher at the moment. Or avoiding a 2x2. If this was yellow, it would be broken. So it is red. Four, 5, 6, 7, 8. This one can only see. Oh no, I can't see 6 anymore. This one can still see 8. Oh, perhaps I do some Sudoku. Let's try that. So 5, I see is making a combo down there with 2. It's gonna put 9 up here. Nothing else for sure. Six, 7, 8. Alright. That's okay. 2s I had. Somewhere over there. It has to go there. This cannot be 6 anymore, so it has to get one more yellow at least. Perhaps 2. Let's say 6 up there. I think with a 5. A 5 is up here. A 6 is up here. And in one of those. There's a 5 up here somewhere. A 7 is going in the middle up here with 5 and 6. So it will get an 8 and a 9. That 5 goes either here or here. Hmm. Oh, these are yellow. I never did mark that. What was that at the very beginning? That is yellow. Red wants out to its buddies. This 3, 4 has a maximum of 6. It sees 4 at the moment. This is, yeah, that's 4, 5 only. This is 4, 5, 6, or 7. Only. Still a 5 somewhere. It could go up here, then it would force 5 there. But that seems okay. It would be there and there. Probably all good. Can that be yellow? I guess it could. All of those would be red though, if it was. Would that create an issue? This would be 9. That would be 9. I don't think it would create an issue. It's this one doing 4, 5, 6, so it cannot be 4 anymore. 6, 7, or 8. The boxes. Oh, 3. 3 finishes that. That cannot be yellow. It would automatically be trapped. This is now 6. That is now 4. That is 4, so it is done. Four. This has a maximum of 7. I mean, oddly enough, we have still not had a color change around the perimeter. That is hilarious. 4 is right there. By Sudoku, making that a 2 as well. 2 is in one of those. That is fine. I think that most of the 2s, not all. 4 has all of them. Six is up here, so 6 is there, and now 6 is there. This will be a 7 or 8. And then there will be a 7 or 8 with a 9 over there. This is 6, 7, 8, or 9. Or, no, it's 7, 8, or 9. This one, 7, 8, or 9. Three. Okay, that's already done. This gets more. It could get all 9 though. All of those could still be 9. Quite easy, I think. Yeah, for sure. I mean, am I just... Should I already know that? That they have to be 9? 1, 2, 3, 4, 5. I guess I should, because look. This is 1, 2, 3, 4, 5. It can't be 1 through 5. So 6, 7, 8, or 9. No, that's not necessarily true. Because these could both be yellow still. And this could be 7, red. So I can't be tricked. I can very easily be tricked. I'm just kidding about that. Can't allow myself to be tricked. Is what maybe I meant to say. So, the question is, if this was to be 6, though, that cannot be 6, right? It could be 5, but it can't be because of that. But if it was 6, then it would have to be 7. So it cannot be 6. Is that the same? No, that is not the same there. So 6 is in one of those two spots. This one, can this one actually be yellow? No, because it would be 2. So it is red, and it can't be 5, and making it at least 6 is making it 8. So it's 8 or 9. That one is red though, because that could not be 5. But this can still be yellow. Or not. So now, does it come down to Sudoku, or does it come down to a box I've overlooked? Here is known now that it stayed 6. We get 6 down here. We get a 6 right there, giving 5, giving 7, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one is 8 or 9. It's gonna be the 8 or 9s, isn't it? The 7 is in this column though, and this column, like such, so it will be there. Now the 7 must go there, and there. And this is going to finish the yellow. 3 plus 4 is 7. And now that must be red, or else yellow would be trapped. Now this is indeed 9. It will put 9 there. We'll put 8 there. 8 there. One, two, three, 4, 5, 6, 7. Regardless, those are red. But that is 9. 9 is in that column, so 9 goes there. This is 8. These will be 7 and 8. This one turned to 9. And now that is 7. And now this is 9. So it was indeed all red around the perimeter. Ah, that is funny. I don't know how I don't remember if I read it at all, or if I just overlooked it. But yeah, if you ever get stuck, that is a good teaching moment. Always go back to the rules. I could have looked at this all day, trying to figure out the perimeter there. If I didn't reread that last rule, all self-indexing cells are one color. So always be sure to read thoroughly. That one is now 8. This one is 5. Placing that 5. Now we just have Sudoku. 8. I did enjoy the puzzle though. Regardless of my struggle, I thought that was a very nice puzzle by Blobz, indexed YYSL. Check it out yourself in the link below, and like and subscribe if you enjoyed. Thanks so much for watching, and have a great day. Bye bye.